Good morning, guys. So today we are going to do a short review on the Vertex form in preparation for our quiz. So let's get started. So with Vertex form, just going to write the formula up at the top of the screen here, just so we have it as a good reference. So it's y equals a times x minus h squared plus k. And then we know that that vertex is the h and the k. All right, so we're going to graph each function. We're going to make sure we plot at least 3, but preferably 5 points. And we're going to label the vertex and the axis of symmetry, and we'll point out a couple other things as well while we go through this. So the first thing generally you want to do is identify that A, the H, and the K in the equation. So for number 1, A is -1. H is +2. So remember, that's always the one where you have the opposite sign of what you see there. And then the K is 8. So this tells us a couple things. First, it tells us the vertex, and we know the vertex is the H and the K. So that's going to be 2, 8. And it tells us that our axis of symmetry is that equation x equals that H value, which is 2. Then a couple other things. So if we wanted to find the y-intercept, that is the point that we get when we put in a 0 for x and whatever we find for y. So we can use that as one of our points. So if I put a 0 in for x here, I have -2 squared, which is +4. Then I would multiply to this negative out front, making it -4, and then adding the 8, which would give me 4. So that's just another point on there. So if I plot my vertex, which is 2, 8, that will be up here. And our axis of symmetry is going through that point. Now, because my A value was a negative, we know this is going to open down, and we know it's going to have a maximum for the vertex. So that vertex is a maximum. We know this parabola is going to be going down, but we want to find a couple points so we can know, how wide or narrow or things like that. Now, we already found the y-intercept, which is 0, 4. So that's one way, and then you can just plot a point on the opposite side of the axis of symmetry, and then you could just go back in and plug some other number in. So let's say I want to pick 1, right, or 3 or something like that. So 1 minus 2 is -1. -1 squared is 1. Becomes negative again when you multiply it here. Plus 8 would be 7. So then I could say, okay, 1 and 7 is right here, and then I could do one on the other side of my parabola. So that's one option, is to just plug in the 0, find that y-intercept, and then another number, and then you've got 2 on each side using the axis of symmetry. The other option I had gone over with you was using that A times 1, 3, 5 graphing pattern. So in this case, my A value is a negative, which will make it -1, -3, and -5. So from that vertex, you would have plotted your vertex, then gone down 1 over 1, down 3 over 1, down 5 over 1, and then you would have plotted the corresponding points on the other side of the axis of symmetry. You should get the same points either way. It's just a personal preference on which way you want to find those points. Of course, if you do need to label that y-intercept, you know that that's the point where the graph is crossing the y-axis, just like the x-intercepts would be the points where the graph is crossing the x-axis. Okay, so then moving on to, obviously we know this is our vertex. So it says to label those things. So our vertex was 2 and 8. And the axis of symmetry is this line here, x equals 2. All right, so we'll do a couple more for some practice. We've been doing this for a few days now, so hopefully you have a pretty good understanding of how to do these graphs. Okay, so number 2, let's see. A is +2, so that's going to open up, and that's going to give us that minimum. H is +3, and K is -5. So my vertex is going to be 3, -5. My axis of symmetry is the equation x equals 3. And then if you want to know any other points, like the y-intercept, for example, you'd have to put in the 0 for x and figure out what that y is. So if I put 0 up here, negative 3 squared is positive 9. 9 times 2 is 18. 18 minus 5 would give me 13. All right, so as far as graphing is concerned, you always want to start with your vertex, which in this case is 3, negative 5. My axis of symmetry is going through that point. And you could plot 0, 13, but that's not going to fit. So we're just going to use the graphing pattern here, which is 2 times 1, 3, 5, which will give us 2, 6, and 10. Now those are going to tell us how many boxes or how many we're going to rise for each box that we go over. So first I'm going to go up 2 and then over 1. Then I would go up 1, 2, 3, 4, 5, 6 over 1. And if I could fit 10, I would go ahead and do that. Then you're going to do the corresponding point on the other side of the axis of symmetry, so it's kind of like a reflection. And then you can draw your parabola through the points. We see our vertex down here, which is 3, negative 5, and it's a minimum. Our axis of symmetry is this vertical line, which is x equals 3. Okay, and then we'll do one more. So for number 3, A equals 1. Since we don't see a number in front, it has to be a 1. H is negative 1, and K is negative 2. So our vertex is going to be negative 1, negative 2. Our axis of symmetry is the equation x equals negative 1. And then we can use that graphing pattern if we want, the 1, 3, 5. Right, which is just going to be 1, 3, and 5, of course, because that's not going to change. If you want to know what the y-intercept is, you got to put that 0 in for x. So 1 squared is 1, 1 times 1 is 1, 1 minus 2 is negative 1. Okay, so plotting my vertex, negative 1, negative 2. Doing my axis of symmetry. And now I can do the 0, negative 1, and get a point on the other side, but I want to use my graphing pattern to get a couple more points. So if I go up 1 over 1, that's the 1 point. Then I can continue up 3 over 1, and then up 5 over 1. And then I can match those up on the other side of the axis of symmetry. There is my parabola. My axis of symmetry is x equals negative 1. My vertex is a minimum, and it's negative 1, negative 2. Okay, so then the last thing I want to review with you real quick is how to put these equations from vertex form into standard form. So in order to do that, and we'll get a little more into this as we go through the next couple days, but you really want to get rid of the parentheses. Now you have to remember, when you have a parenthesis that's being squared, you're going to write it 2 times, and then we're going to have to FOIL that or distribute. So I'm going to focus on just distributing or FOILing these two. So if I did x times x, I get x squared. X times 5 is 5x. 5 times x is another 5x, and 5 times 5 is 25. Now that can combine to give me x squared plus 10x plus 25. And that's all stuff we learned in an earlier chapter. Now at this point, we would have to now distribute this 2 to everything in those parentheses. So that will make that 2x squared plus 20x plus 50. And then we have to subtract that 8. So our final answer is 2x squared plus 20x plus 42. And of course, it's still y equals. So this is our answer right there. Now it's in standard form as opposed to the vertex form. All right, so we're going to do a couple more, just practicing with this multiplying here. So this one is nice because there's no number in the A location there, the A spots. We don't have to worry about distributing that. All we have to worry about is multiplying the x plus 1 to itself. Now, if you remember in the last chapter, we did learn a little shortcut pattern you could use. If you remember that, great. It'll save you a little bit of trouble on the FOILing. So x times x is x squared plus 1x plus 1x plus 1, and then we have that plus 2 at the end. Now, since I don't have to distribute any number from the front, I can just combine those like terms there, giving me a 2x, and I can combine the 1 and the 2 here, giving me the 3. So my standard form of that equation would be y equals x squared plus 2x plus 3. All right, now 6 and 7, we're going to have to distribute out that extra number in the front again, like we did on the first example. So when we do this one, I'm going to leave the negative out there, which is really a negative 1. We have x plus 6, x plus 6. And we're going to FOIL those together first. So we have x squared plus 6x plus 6x plus 36. Now remember, all of that needs to get that negative 1 distributed. And don't forget about the plus 10 at the end. So now basically all these signs are going to change. So I'm going to have negative x squared minus 6x minus 6x, which of course is going to combine to give you a negative 12x. Some of you might have already done that. And then minus 36 plus the 10. And then the negative 36 plus the 10 will be then negative 26. Okay, last question. We have 5 times x plus 3 times x plus 3. So first I'm going to FOIL out these two binomials here. So I'm going to have x squared plus 3x plus 3x plus 9. Now it's up to you whether you want to distribute the 5 first or combine these like terms first. So I'm just going to make this a 6x in the middle first. Now I distribute the 5 to those 3. So that's 5x squared plus 30x plus 45. And don't forget you still have that little 4 at the end. That's sometimes people forget about that. By the time they get to the end, it's like they lost it somewhere. So 45 minus 4 would be 41. Okay, so going from vertex form to standard form, all you're doing is writing out that binomial the 2 times and FOILing it out and then just combining any like terms. We did do a few things like that back in chapter 8, but it's been a while, so just kind of refreshing that. But for the most part, our quiz tomorrow is going to focus on the graphing and the different components and parts of the graph. You should be able to, tell if it's in standard form or vertex form if they ask about that and any of those questions. The only thing I want to review really quickly is domain and range. So you should know that domain is always all real numbers and range is always that y value. And it's going to be greater than or less than depending on if it's a min or max, right? So if that a is a negative and your graph's going to be going downward, then all the y values are less than or equal to that vertex. So it's less than or equal to this 8. If we were doing number 2, our domain would still be all real numbers, but our range would be y is, since it's opening up, everything has to be greater than or equal to that k value, which is negative 5. And then the domain and range for number 3, again, domain is always all real numbers, but the range in this case, the y value would have to be, since it's opening up, all the y values are greater than or equal to that k value there of negative 2. And that pretty much concludes graphing in the vertex form. So we've done, reviewing all that. We've hit all the different components of graphing in vertex form over the last several lessons. And you will have a little quiz on that tomorrow. So enjoy the rest of your day and don't be afraid to reach out if you have any questions. Thanks.